Okay, today we're putting it all together. We're finding the zeros of a polynomial. So the first thing we need to talk about is what do I mean when I say finding the zeros or solving it? Well, if I give you a polynomial, when we're finding the zeros, we're basically finding where x or y is 0. Because when you graph it, that tells you whether you're along the y-axis or along the x-axis, where the points actually would meet, which will make it easier to graph later on. So, if I give you a polynomial like this, y equals x squared plus 5x plus 6, finding the y-intercept's still pretty easy. You just set x equal to 0, and if you notice, anything with an x vanishes, and you end up with 6 being the only thing that's left, right? Because plugging in a 0 is there, multiplying 5 by 0, you still get 0. So the y-intercept would be 0, 6. But finding the x-intercept when y is 0 is harder. I mean, how do you actually solve that for x? Because you can't add the x squared and the x. So I can't simply move things around and I can't cancel them out. How do I actually solve something that has an x squared and an x? Well, the good news is you already know the answer. It's factoring. So the way you solve that mess is actually factoring. This is the reason we would actually want to change something from its standard form into its factored form, because this is actually really useful. Now, because anything times 0 makes the answer 0, if this is 0, no matter what this is, it's going to be multiplied by 0 and equal 0. And if this is 0, no matter what this is, it's still going to be multiplied by 0 and it's going to be 0. So there's actually two solutions. One is when x plus 2 is 0. One is when x plus 3 equals 0. So if we solve those two cases, you can actually find the two answers. Because, as I said, 0 times x plus 3 will be 0. 0 times x plus 2 will be 0. So as long as either of these is 0, you're going to get a final answer for y of 0. So how do you do it? Well, first off, you factor it. So we take that and we factor it. X plus 2, x plus 3. So it adds up to 5, multiplies to 6. Then, for when it's equal to 0, we know this for this to be 0, so you'd be at a y point. X plus 2 has to be 0, in which case we can just bring the 2 over and we find that x is minus 2, right? Because minus 2 plus 2 will give me 0. Or when x plus 3 is 0, in which case x is minus 3, because minus 3 plus 3 again gives me 0, and anything multiplied by 0 will give me 0. So the values of x that work are minus 2 and minus 3. So your 2 points would be minus 2 when y is 0, or minus 3 when y is 0. And in fact, if you look at the graph, this is actually what we get. So there are two solutions, and you may say, well, why are there two solutions? Well, because there are two solutions in real life when we graph this. It is actually at y equals 0 at 2 points equal to minus 3 and minus 2. By the way, if you look where x is 0 is that plus 6, which we had already figured out. So there are two solutions. Because it's a parabola, it can hit at 2 points. So there might be two solutions. So if we say our equation describes this curve, then our equation better have two solutions, two numbers where it actually does do that. So let's say we're finding these zeros. X squared minus 8x plus 15. So the y-intercept again will just be 15, because if you make the x a 0, that's all that's left. To find the x, that's why we typically, when we see zeros, we're talking about x, because finding the y is usually pretty easy. To find the x, we factor it. Minus 5 minus 3, because those add to minus 8 and multiply to plus 15. Then you figure out what makes this equal to 0. So it's 0 when x minus 5 equals 0 or x minus 3 equals 0. So x is either 5, because 5 minus 5 gives me 0, or x is 3, because 3 minus 3 gives me 0. So the zeros are at 5, x5, y0, or x3, y0. So my solutions for this are when x equals 5 or x equals 3. And again, if you graph it, you'll notice you get exactly the same thing. You get your points at x equals 3 and x equals 5. By the way, that's a great way to test. Just put the equation in Desmos, graph it, and it should give you the exact answer that you got when you solved it. If it doesn't, something's wrong. By the way, this actually does exist in real life. There are things like when you throw a ball, it moves in a parabola. And in fact, there are 2 points when you kick a ball. Let's say you kick a soccer ball off the ground. there are actually 2 points where it will be at y0, when you kicked it and when it lands. So a parabola in real life has to have 2 points where you're on the ground. Makes sense. So how do we do it? Well, here's what a solution would look like. Step 1, factor it. Find out what adds to minus 10, multiplies to minus 24. Well, minus 12 plus 2 gives me minus 10. Minus 12 times 2 gives me minus 24. So you know it's x minus 12, x plus 2. So your zeros, your solution has to be when x minus 12 is 0, so x is 12, or x plus 2 equals 0, x is minus 2. So your answers are 12 and minus 2. Now, this sounds kind of weird, but honestly, doing physics, which I realize you may not do a lot of physics, this is actually the most useful bit of algebra I have ever used. We do this all the time. If you end up taking my grade 12 college physics class, you're going to be doing this because this is actually how we do things in real life. What the whole point of this is, if we know something moves with an equation, we can solve the equation to actually figure out what's going to happen. And this is how we know everything in real life and can predict things. All right, so that's how we solve. So when I say solving, I basically usually mean solving for x when y equals 0. All right, finding your intercepts, your zeros. What is x when y equals 0? All right, good luck with the worksheet. Contact me if you have any trouble.